Okay, let's try to get started. If you are not participating on the lecture, or well, demo lecture of software engineering methods, you are welcome to stay here, provided that you are staying quiet. I don't want to have a yelling contest with people who aren't participating on this course. Otherwise, if you are participating on the software engineering methods, then welcome. This is the third demo lecture, and we'll start right after we get the image on the screen. Now, there, good. So, today our topic is a sort of a reminder. The talk I'm going to give here is about the actually using UML in software industry. It has parts which more or less have been discussed on the lectures, but it's more or less a reminder. The demo case is a sort of a mini project which has activities which are similar to things that you are expected to do on the actual project work. So, if you haven't been participating on the exercises of the first period, or you have not started the project 2 before this is something that should enforce trying to actually draw something on UML. For other people, it's a small exercise, and it's a reminder on how to draw different diagrams and how to try to set or synchronize information between the UML diagram types. So, on this big picture of software development, today we are around here somewhere, doing the UML design, analytical architecture, and also talking about how the UML is used on the actual architecture, the design of actual components. The talk isn't going to be that long, but anyway, it should give you some idea. So, anyway, the UML2 notation is one of the core topics of this course. The idea with the UML is not that you should start doing the documentation on each and every item you are ever going to develop or design, simply because that's really not a feasible approach. I said on the lecture, and I say it again now, that if you would be doing all the different UML diagrams on your software project, even if your work was sort of a small one, talking about something like 10 million lines of code, meaning that it has less than 100 people working on it, and it would take something like 50 to 100 megabytes of disk space. The documentation, including all the different aspects from the top level hierarchy of use cases down to the detailed explanations how different functions or objects work, and all the different versions and revisions of them, would probably fill out a small-sized library. So, of course, since we are developers, our task is to develop software. Like said on the documentation last week, if we have a bad way of doing documentation or unsuitable process which requires information that's of no use to the organization, the process model or documentation model is abandoned. Similarly here, if you aren't using the diagram types for anything, why should you then be drawing them? Also, if your company is completely satisfied with the diagram or design approach, where you simply say that, okay, this is something that it's going to look like, then why start to draw some sequence diagrams or activity diagrams when we are more or less familiar with all the aspects? However, UML is not a tool that has no purpose or a tool that is too complicated for its own good. For example, the use cases and the deployment diagrams, also class diagrams, are fairly common in the industry. And with my experience from 50, 60 software companies I've been working with, I'd say that around 1/3 of them, 20 companies, so more or less, apply some form of use cases or deployment diagrams or class diagrams, simply to give the idea for the developers of what's related to what, and if they have to revisit something like modules, they can find the information on what modules affect what. Like I said on the lecture on the object-oriented design and object-oriented thinking, the idea is that we design modules and components so that we can actually take one component out, replace it with more functional or more modernized version, put it back in, and then our software would be functioning correctly, although a bit better than earlier. Similarly thinking as with the combustion engine. We can take out the air intake, exchange the manifolds, and do some magic on the ignition system to increase its performance. The similar idea would be useful in the object-oriented design. And of course, since the programming projects are large enough that there's no way one person can keep all the little details in mind, this is where the UML is actually really beneficial. It's something that gives us a way to illustrate or give a visual design on our ideas on how to solve certain problems. Since programming constructs don't have any visual presentation otherwise. We can't see what the iteration or search indexing module looks like, nor can we draw one, because it's just bits in the computer's, bits and bytes in the computer's hard drive and memory. We have to have a way of doing visual design. So the UML2 is for that. It enables the knowledge transfer and visual presentation of programming concepts and ideas, and it's really useful to provide the developer with some idea on what happens beyond their own little sandbox of work. If you are doing software development, you more or less have to work with one component. You are stuck with the database or support tools or user interface or event handlers or network adapters or something like that. And for the entire duration of the project, you have absolutely no idea what happens beyond your little safe zone of activities. So there's the place for the UML. And on this list, which I just recently added, actually the point 5, I've collected some usages or ideas of how the UML is actually applied in the industry. So definitely the use cases are most common. That's because they are one way to design the user interface. Also the class diagrams, domain models, business models, abstract models, which can be extended to something like boundary control entity model, which we'll be talking next week. These are really useful. Of course, the deployment diagram also, because for the people doing the development work, it actually answers to quite many questions. You know about the database structure, you know about the client-server structure, you know about the different needs for security, and what sort of thing we are actually building by seeing how it's deployed. If you are creating a thin client on smartphone, then you probably don't need to have certain heavy lifting capabilities on the local system, and if all the actual activities happen on the server side, of course, then that's the place where the computing capabilities or memory is not a problem. Additionally, there's a couple of really nifty and useful tools. For example, the sequence diagram, which we are currently unable to draw with the Argo UML tool, simply because there's a bug on the newest version of the drawing tool, but which we can draw with the Visio, is really good at defining client-server communication, simply because it has timeline as one of the axes, so you more or less see what should happen when the client and server are communicating. Yes, I know that the bug I mentioned only affects the WebStart version of the program. You could use it if you had local installation, but unfortunately we only have the WebStart available here, so we cannot draw the sequence diagrams with that tool, but that means that if you want to use them on your project work, then you should probably look at the Visio drawing tool for that. Of course, there's also the state machines, which are very much used on the mathematics and logic calculations. There's several different ways of defining things, but that's actually also really used on embedded systems development, or these are actually not in the development but on the design of embedded systems. It's quite straightforward, and it also has the ability to show enough information about the otherwise a bit complicated aspect. And finally, the activity diagram is actually useful not because it's accurate. Obviously, it's not very accurate. It's actually one of the most abstract diagram types in the entire UML, but simply because it's so versatile. You can use it for many things, to describe how someone logs in, or how someone fights player versus player match on online game, or how some order info goes to billing and warehouse and all the other places. So that's actually one of the more useful tools, simply because you can show or define so many things with that. But anyway, these are more or less the more useful parts of UML. I know that some of you might actually disagree on some points here, or that someone, especially people following this presentation later from the internet, might think that, oh God, this person is a complete idiot, he didn't mention this and that and those things. But unfortunately, these are more or less the only ways I have personally seen industry companies use the UML. I know that there's several parts more, and I know that if I would be working with someone in the United States or India or China or Japan, or possibly in the military industry complex or space industry, then I'd probably see more detailed information, and I would be seeing the usage of the more detailed diagram types. But unfortunately, I'm not there, and neither are you, at least not for now. You are in Finland and, well, in Northern Europe, really. So at least these are the things that happen with the local companies if you end up working for the software industry here. This can be compared to all the different chart types of UML2. So there's wealth of different information, And it's actually noteworthy that these different diagram types represent all the main branches of the UML charts. The structure in class diagrams and also in deployment, the behavior with state machine diagrams and activity, also use cases, although the use case diagrams describe the behavior with the written instructions, not so much with the actual diagram. And finally, the interaction diagrams are represented by sequence diagram and also communication diagram if someone decides that they want to draw the sequence diagram a bit differently. The difference between communication diagram and sequence diagram is really that the sequence diagram is drawn on the time as the main axis, whereas in the communication diagram it's the order of messages. So basically they have the same information. With sequence diagrams we can actually do something with the showing of time, how the time passes by when things happen. On these diagram types, I have to say that the composite structure diagram, timing diagram, are two diagram types I have never seen outside academia or research white papers. I know that the timing diagram has its uses on mission critical embedded systems, something like anti-lock brakes and stuff like that, but it doesn't, but it still doesn't change the fact that it's really, really rare. It's actually rare enough that because it was added with the UML2, there's actually a problem of finding a diagram editing software which can draw the timing diagrams, simply because it's so rare occurrence in the industry that the open source software or even some of the commercial design software tools don't necessarily support that diagram type. So you can make your own judgment based on that. But anyway, it also means that since all the different structure types are represented, this 4+1 views into the architecture is also somewhat accurate. Like with the building, the architectural design for buildings, there's separate plans for the facade, the electric connections, the wiring, all the different air conditions, air conditioning, airflow in general, and other things. So this model here does the same for software. We have class diagrams and state machines telling us what components will be made and how they will behave, more or less. There's activities defining how concurrency and synchronized aspects happen, or how the software behaves in a real world. So the user pushes button on the web store and stuff starts to happen. Of course, we have to know what that stuff is because we are designing the software. So that's why we also have to have the way to show it. The development view, how the assets are organized, it has only component diagram and package diagram. That's something that I would guess that if we were doing a really, really large software project, would be more represented, but for now, both of those package diagram types are somewhat rare. The package diagram is usually something that simply appears because the version control system more or less has the branches available for different modules, and because the modules are developed separately, that also ends up being some sort of a package or packaging diagram for different parts. The physical view deployment diagram, like I said earlier, how software and hardware are related and where things actually R is also one of the more applied approaches. This is actually important for things like assessment of the real world connection, network availabilities, for example. So we have to know which places require, for example, landline connection for the internet. Because if we have, well, an elevator, this is a good example because I know something about how the logistics there work. The elevators usually try to apply sort of a landline connection because the mobile phone approach is somewhat unreliable. Also, landlines power themselves. So even if you have an extended power out, you won't lose the ability to call for help if you are locked in an elevator system. Well, that's just one thing. Also, well, if you have database somewhere, you would probably want to access it and all these other things. Finally, the use case diagrams here in the center are actually the most used approach from the UML. Even if some companies don't even say that they use any part of the UML, they still do use cases. So considering what are the most important or almost omnipresent parts of the UML design of the software industry, they are the use case things here, and all the other things are, well, more or less used if they are considered appropriate. So I've given a long presentation on how the UML diagrams work. So I'm not going to go through these things again here. I just put them here on the presentation to give a reminder on what these diagrams look like. So the class diagram is this one. It has all the different main concepts described, and it can later be extended or evolved into something that actually has some considerations for physical things or abstract things, or well, actually technical things like database connections and network interfaces, and how, for example, the search engine or algorithms are included into the system. So it starts with the high-level domain model, then evolves along the way into technical model, which then goes to something that describes the actual technical architecture. Of course, it means that these, well, indexes or places, for example, for the person here, are exchanged for something that describes a database. And of course, when we have database, then we have to have some control mechanism, and we have to have some interfaces for the actors to use. So, but anyway, the class diagram can be used to describe either the high-level domain and high-level concepts, or actually be used to evolve into something which is more technical and usable. But this is something we will talk next week. The deployment diagram here, especially the one with the UML2, is one of the more descriptive diagram types. It doesn't leave much to imagination. It doesn't actually require you to have that much information on how different things work or what the different symbols mean, because it's more or less straightforward. How the system has to be installed, what components we have on the system, and where do they exist, so that, or where are they installed, where are they running, so that we can see, use the software and all the other things. It doesn't, the first version doesn't have to be that accurate, but along the way it should mature into something that shows, for example, the DMZ areas for example, or the different system areas. The activity diagram is this one, and on this example it's just showing some outcome for negotiations. It can also include several things like describing step by step how some use case happens or what the user does when they are trying to achieve something. What goes inside into each of these bubbles here, or activities there, can be basically anything. It can be something simple like insert card into the slot or launch a rocket into the moon. It doesn't really care. It just expects you to follow the steps like a recipe. There's potential for concurrent work, or there's also the ability to use the swim lanes, which aren't in this example but are on the exercises example. For example, describing all the different things that happen inside the user's head, or which happen in the local system, or things which happen in the server-side system. And this one is, of course, the use case diagram. We've seen this one several times. This is the use case diagram I'm asking you to do this time is probably something like 7th or 8th version of the diagram type, so I guess there's nothing really much to say anymore here. Just keep in mind that you can use extend or uses relationships between the use cases so that you don't have to start each and every use case with describing how the PIN number is entered and validated. Or well, you can also do that, but it goes against the pragmatic approach trying to keep it simple. So even though we have the descriptive approach here, it doesn't mean that we actually have to act like idiots and do copy-pasting work to make our document look more trustworthy, because it takes all the little things into account. So what I'm trying to say here is that when you are using the UML in this project, in the next course, in your professional work, wherever, try to give correct information, but also try to try to be brief and coherent in your work. No one reads a document which is filled up to the brim with bullshit. It's just going to end up on your database server, and no one ever will see it after it's been inserted there. So these are my, let's say, keynote words for working with the UML. Let's check out the case. And if everything works correctly, we have it here. So, like I said earlier, this one more or less revisits the topics which are related to the project 2 and the exercise tasks from the earlier course. This week you are tasked to design a ticket purchase system. It's really simple system. There's a couple of booths in one building or one area, and you have to be able to dish out 300 tickets per night. If you sell 300 tickets, then you are sold out for the evening, and that's that. There should also be a separate online system to check out if there's still tickets for this evening's activities, and there should be ability for the customer to pay with cash or credit card. So there's several things which are similar to the earlier exercises, but still some differences. What you are tasked to do is to draw the use case diagram, domain class diagram, and deployment diagram for the described system and its functionalities. Additionally, there's 3 cases for different activities on which I require you to draw the activity diagram. And keep in mind that on this part, I'm going to look into the details, or how these different diagrams work together. I don't, well, of course you can submit me work which has just random stuff in it, but the idea is that all the activity diagrams, use case diagram, class diagram, and deployment diagram should support each other, so that there is no information which is completely against things mentioned or described on the other diagrams. If you are uncertain on how you would describe this correctly with the UML, you can also write written descriptions, but try to work with the UML diagrams and try to aim for using the diagram types correctly. We have had so many exercises with these types of diagrams that I hope that I can start to expect at least a tiny flick of professionalism or expertise from you. Don't prove me wrong on this aspect. Okay, finally, since I think that some of you may leave when I'm done with this talk, I'll just quickly show you the new part of the project work. So there's not that much to add actually. There's a couple of additional requirements which may or may not require you to scale up your design, or at least rethink some aspects of your work. You can go through these at your own time. What you actually are required to do is to draw the deployment diagram of your project to work, how it connects to existing services, and finally provide some free-form description of how you think that all the different activities work. Meaning that besides the deployment diagram, you can also illustrate your work or your ideas, how these things will happen and what sort of aspects we will have and what sort of hardware and things we will have on the system by drawing freehand. Don't use Paint, but use so to say free-form diagrams or free-form illustrations, or to show how you think that this entire system will work. Otherwise, there's still two parts to come. The part 4 is one which includes some technical stuff, but the part 5 is more or less just a summary and checklist for you to see that you actually remembered to include all the different diagrams and all the different required things into your work. Okay, good. Do we have a question at this point? Just raise your hand. If not, I'll give you, let's see how much is the clock now. I'll give you about 20 minutes to get, to read through the case descriptions and start doing something. I'll give you a couple of pointers on how to, design your work if you are completely stuck with your work. And otherwise, it'll take a couple of minutes for me to stop the recording and put the slides online, but all the slides are already available on the lecture recordings and on the lecture slide archive on slides 3 or 4 or something like that. You can find them also from there. Okay, start to work, go have lunch, go home, whatever. I'll be here to answer your questions, and in 20 minutes I'll give you a couple of pointers.